Let's try a mathematical riddle. I am a part of a whole, a fraction, they say, to trouble many with my props or tricks. Here I come again. I become 1 by 3 when 1 is subtracted from my numerator, and I become 1 by 4 when 8 is added to my denominator. Figure me out and you win. Let us begin with step number 1. Identify the unknown parameters. What is the riddle asking us to figure out? Yes, the fraction. A fraction has two components, a numerator and a denominator. We will denote the numerator with the variable n and the denominator with the variable d. Fraction is equal to numerator upon denominator, which is equal to n upon d. Let us move on to step number 2. Form a pair of linear equations. Which lines from the riddle can we use to form the equations? Yes, for the first equation, let's use I become 1 by 3 when 1 is subtracted from the numerator. The fraction becomes 1 by 3 when 1 is subtracted from the numerator and the denominator stays the same. On cross multiplication, we get 3 times n minus 1 within brackets is equal to 1 times d, which implies 3n minus 3 is equal to d, which implies 3n minus 3 minus d is equal to 0, which implies 3n minus d minus 3 is equal to 0 after rearranging the terms. Our first linear equation. For the second linear equation, let's use I become 1 by 4 when 8 is added to my denominator. The fraction becomes 1 by 4 when 8 is added to the denominator and the numerator stays the same. On cross multiplication, we get 4 times n is equal to d plus 8 times 1, which implies 4n is equal to d plus 8, which implies 4n minus d minus 8 is equal to 0, our second linear equation. Let's move on to step number 3. Solve the pair of linear equations using a method of your choice. We will stick to elimination method for this one. We will multiply equation 1 with 4 and equation 2 with 3 so as to make the coefficients of n same. On multiplying equation 1, 3n minus d minus 3 is equal to 0 with 4 on both sides, we get 12n minus 4d minus 12 is equal to 0. On multiplying both sides of equation 2, 4n minus d minus 8 is equal to 0 with 3, we get 12n minus 3d minus 24 is equal to 0. Now let us subtract equation 2 from equation 1 to eliminate n and figure out the value of d. 12n minus 4d minus 12 is equal to 0 minus within brackets 12n minus 3d minus 24 is equal to 0. On opening the bracket, the minus sign will affect the signs of the terms within the bracket. 12n will become minus 12n, minus 3d will become plus 3d, and minus 24 will become plus 24. 12n minus 12n is equal to 0, minus 4d plus 3d is equal to minus 1d, and minus 12 and plus 24 will give us plus 12. On the right hand side, 0 and 0 will give us 0, which implies 0 minus 1d plus 12 is equal to 0, which implies minus 1d plus 12 is equal to 0, which implies minus d plus 12 is equal to 0, which implies minus d is equal to minus 12, which implies d is equal to 12. Putting the value of d in equation 1 to figure out the value of n, we get 3n minus d minus 3 is equal to 0, which implies 3n minus 12 minus 3 is equal to 0, which implies 3n minus 12 minus 3 is equal to 0, which implies 3n minus 15 is equal to 0, which implies 3n is equal to 15, which implies n is equal to 15 upon 3, which is equal to 5. With this, we have figured out the values of both n and d. Step number 4. State the solution to the riddle with the correct units, if any. We don't have to worry about the units since a fraction does not come with units. N, our numerator, is equal to 5 and d, our denominator, is equal to 12. Therefore, the fraction is equal to 5 upon 12. We would like to leave you with something to think and wonder about. Can you verify the correct answer to our riddle is 5 upon 12 using the lines given in the riddle with the help of graphical arrays? Example, 5 upon 12 can be represented as a graphical array in the following manner. Check how will the graphical array change when you subtract 1 from the numerator and verify your answer, and then check how will the graphical array change when you add 8 to its denominator and verify your answer.